Hello my dear students, I welcome you all for SVK tutorials. In this topic I am taking Cauchy Reimann equation in polar form. I am going to derive an CR equation in polar form. So I can take the statement of if f of z equal to u of r comma theta plus I into v of r comma theta be an analytic function, then show that del u by del r is equal to 1 over r into del v by del theta, and del v by del r is equal to minus 1 over r into del u by del theta. So also it can be defined in another way. U r is equal to 1 over r into v theta and v r is equal to minus 1 over r u theta. So this is the way of representing polar form in CR equation. So now we require to prove this. We shall go for proof. So let f of z equal to u plus iv be an analytic function, and I will name this as equation 1. And also let us define a z. Let z be an polar form, z equal to r e power I theta, z equal to r e power I theta. Let z equal to r e power I theta. Then equation 1 implies, implies f of r e power I theta is equal to u plus I. I'll name this as equation 2. Now differentiate this equation 2 partially with respect to r. Differentiate partially with respect to r. So I am going to get the differentiation of f is f dash of r e power I theta. The inside function is r e power I theta. The derivative of r with respect to r treating theta as constant is e power I theta. This is equal to derivative of u with respect to r is del u by del r plus I into del v by del r. So I'll name this as equation 3. Now again differentiate equation 2 partially with respect to theta. So I am going to get as it is, say f dash of r e power I theta. Now derivative of r e power I theta, r is a constant, derivative of e power I theta is e power I theta into I, as we are differentiating with respect to theta, which is equal to del u by del theta plus I into del v by del theta. We can rewrite this equation retaining f dash of r e power I theta into e power I theta in the left hand side, which is equal to, I will shift ri, so that becomes 1 over I r times of del u by del theta plus I into del v by del theta. So I will name this as equation 4. Now equating 3 and 4. So equating 3 and 4. Since the left hand side is same, we can equate the right hand side of equation 3 and 4. I am going to get del u by del r is equal to del u by del r plus I into del V by del R is equal to 1 over I R times of 1 by I R times of del U by del theta plus I into del V by del theta. Now multiplying 1 over IR, so it becomes 1 over I is nothing but minus I. We can rewrite that afterwards. 1 over R into del U by del theta. Here I by I get cancelled. I by I get cancelled. I by I get cancelled. You are left out with del V by del theta. So 1 over I is nothing but minus I, as I told you earlier. 1 over I is nothing but minus I into 1 over R into del U by del theta plus 1 over R into del V by del theta. So therefore, rewriting this del U by del R plus I into del V by del R is equal to 1 over R into del V by del theta, which is plus of 1 I times of minus 1 by R into del U by del theta. Now equating real part and imaginary part. This is real part and this is imaginary part. Equating real part and imaginary part, we are going to get del U by del R is equal to 1 over R times of del V by del theta, and del V by del R is equal to minus 1 over R into del U by del theta. Is the so this is the required CR equation for polar form. Therefore, CR equation in polar form. I think you all understood the derivation of CR equation in polar form. If you like this video, kindly do subscribe to my channel for more videos, and also don't forget to press like button, and also I wish to share this video to your friends. Thank you all.